15 hidden gemstones for the discerning collector. The history of gemstones is usually told through names everyone knows: diamond, sapphire, ruby, jade. Their stories are repeated in books, museums, and markets. But beneath those familiar chapters lies another record. Stones so rare, so poorly supplied, or so difficult to define that they never entered the systems of trade. These are not the gems worn by monarchs or advertised by jewelers. They are the fragments that appeared briefly, disappeared without warning, and remain largely unseen. Each entry exists, is measured, cataloged, and held. Yet each resists the usual paths of commerce and culture. This is not a ranking of value or beauty. It is a record of what survives outside circulation. 15 gemstones that remain hidden, sometimes in plain sight, locked away, sometimes known only by name. The journey begins not with what the market celebrates, but with what it has almost forgotten to include. Don't forget to press and hold that like button, leave a comment, and hit subscribe before we begin. Ranked 15th, Kornerupine, the bicolor secret of Sri Lanka and Tanzania. The first time Kornerupine was extracted intentionally, it wasn't for the gemstone trade. It was a byproduct of early mineral surveys in southern Sri Lanka during the colonial mapping era. To most geologists, it was misfiled, first as tourmaline, then as andalusite, and once even as altered apatite. Not until Lacroix published his orthorhombic classification in 1884 did it earn a name. Even then, no one knew what to do with it. The stone's problem was its precision. Kornerupine requires borosilicate conditions in high-pressure metamorphic zones, yet very few of those zones yield transparent crystals. And when they do, most pieces are thin, fibrous, or fractured. Cuttable, gem-quality Kornerupine is a statistical anomaly. In Sri Lanka, a few mining families once attempted to organize direct supply, only to find that the stone resisted polishing and confused buyers. It didn't have the name recognition of peridot or the hardness of spinel. It was removed from catalogs by the 1980s. No one complained. Then came the Tanzanian material. In the early 2000s, near Umba Valley, a batch of Kornerupine surfaced in pale green-brown tones with enough clarity to facet. A few found their way into the collections of Swiss dealers who specialized in optical rarities. Not one piece made it to mainstream television. What makes Kornerupine valuable to certain collectors has nothing to do with fashion, history, or investment. It is about behavior. Under polarized light, a well-cut Kornerupine doesn't just shift color. It fractures expectations of how light navigates silicate bonds. It offers no showy fire, but instead a subdued tone. Even gem labs struggle with classification. Refractive index overlaps with sillimanite. Bare fringence is subtle. Some Kornerupine shows trace vanadium, others none. There is no standard commercial treatment, and thus no commercial story. What is the current number of known transparent, untreated Kornerupine gems above 2 carats? Fewer than 150 documented. No mining operation is currently active. No future supply has been projected. And yet a single drawer remains. Third row, box 4, code SRL-mix-1979-B. The label has been added, not for sale, archived. Ranked 14th, Scapolite, the forgotten golden crystal. It had no cracks, no inclusions. The cutter's note read, 3.18 carats, eye clean, golden yellow. But the stone was pulled from the parcel and removed from the offering tray. Not because of damage, not because of clarity, because of its name, Scapolite. A mineral group most gem buyers have never heard of, and most dealers won't bother to explain. Not a marketing failure, just a structural one. The stone never had a place to belong. Scapolite is not a singular gemstone. It's a mineral group composed of 2 end members, Maonite and Mariolite, linked by a continuous series. Chemically, it's a sodium-calcium aluminosilicate with chlorine, carbonate, or sulfate trapped in its lattice. Geologically, it forms through metamorphism of feldspar-bearing rocks, especially under volatile-rich conditions. But those aren't the kinds of sentences that sell jewelry. In its standard form, Scapolite appears as white, gray, or milky yellow crystals. Most are opaque. some fractures on contact. They are of interest to geologists, but not to gemologists. And yet scapolite forms very rarely in clean, transparent crystals. When it does, it can exhibit subtle pleochroism. Under UV light, some varieties fluoresce orange or change color entirely, a behavior known as tenebrescence, shared by only a few minerals on Earth. These rare optical traits have made scapolite specimens a quiet obsession among mineral collectors. But among jewelry designers, the stone never gained traction. The problem isn't beauty. A golden scapolite can resemble a citron or imperial topaz until you measure its hardness. On the Mohs scale, scapolite sits between 5.5 and 6, too soft for everyday wear. That alone disqualifies it from bridal, high jewelry, and commercial mass production. In the 1970s, deposits in Canada produced gem-quality scapolite, sparking brief excitement. A few pieces entered private Western collections. Gem cutters praised its polish, but market demand was nearly zero. In the 1990s, Tanzania revealed pale purple and golden varieties, some clean enough to facet over 5 carats. Still, the story repeated. No major house picked it up. No lab report elevated its name. It remained a mineralogical note in the side catalogs. Even when the stone reaches retail, it's misnamed yellow moonstone, light topaz, or Tanzanian amber. No one mentions the word scapolite, and when they do, the sale disappears. Collectors in the know, mostly lab scientists and private gem curators, treat gem scapolite as a kind of controlled variable. It doesn't explode in value. It doesn't appear in fashion editorials. It stays stable, quiet, and traceable. But that raises a question. Why must a gemstone be durable to be valued? Why must a name be marketable to be remembered? Why must a material succeed in trade to matter in science? The mistake was never scapolites. The criteria may have been wrong all along. Ranked 13th, Zektzerite, soft pink with zero public awareness. Sample 042B showed cleavage in 3 directions. Pink tint, low luster, estimated hardness between 6 and 7, no known economic application. It was July 1967 when a survey team in Okanogan County, Washington, encountered the pegmatite band that held it. The expedition wasn't looking for gemstones. It was mapping alkali mineral zones rich in zirconium and lithium. But amidst the eudialyte, quartz, and vedsanite, there was an unfamiliar crystal. It was pale, sometimes salmon pink, sometimes nearly colorless. It broke cleanly but unpredictably. It took months to isolate and test the structure, and only in 1976 did it earn a formal name, Zektzerite, after geologist Jack Zektzer, who led the mineral survey team. But outside that act of naming, the stone never moved further. Zektzerite is a lithium zirconium silicate that forms under particular geochemical conditions. It is monoclinic, with a complex silicate framework, and appears only in small quantities at the Washington Pass pegmatites. No other deposit has been confirmed, and even at the source, the crystals are typically less than 1 centimeter long, rarely large enough to facet. On the few occasions that gem cutters attempted to work with it, they reported difficulties including uneven cleavage, brittleness, and unpredictable fracture patterns. Even when polished successfully, Zektzerite resists classification. It lacks brilliance. Its color is subtle. Its behavior under light is restrained. There is no jewelry market for Zektzerite, no treatment protocol, no standard pricing model. The Gemological Institute of America does not include it in standard grading references. Most collectors will never hear its name. And yet Zektzerite exists. One of the few fully faceted specimens resides in the Smithsonian's National Gem Collection. Another lies in a private university archive in Oregon. Occasionally, a few small, polished stones appear at mineral shows, priced not by carat weight, but by context, by proof of origin, by the fact that they were cut at all. Unlike commercial gemstones, Zektzerite does not move through hands. It moves through papers, lab reports, thin section slides, academic journals. It travels not by markets, but by citations. There is no forecast for future mining, no pending exploration, no artificial synthesis. The only place it comes from is the only place it has ever come from. And the only people who possess it are those who ask the question, what was that pink shard in the granite wall, and why did it fracture like that? No investment portfolio tracks it. No fashion brand names it. It is present, studied, measured, and logged. And that is enough. Ranked 12th, Ekanite, the crystal that erased itself. The crystal was still holding its shape, barely. A soft greenish hue under low light, a surface neither entirely glossy nor matte. Beneath that surface, the breakdown had already begun. What looked stable was quietly dissolving, not from heat, not from pressure, from within. Ekanite, first identified in 1953 by FLD Ekanayake, is a calcium-thorium silicate that challenges every convention in gemology. It can be transparent, it can be cut, it even holds a faint, glassy brilliance under raking light. And yet it is unstable. The mineral is naturally radioactive. It contains thorium, and in some samples, trace amounts of uranium are also present. Over time, the alpha particles emitted from within rupture the atomic lattice of the crystal itself. The structure disintegrates, not explosively, but gradually, invisibly. The technical term is metamictization. A crystalline body becomes amorphous, not destroyed, just rearranged into disorder. In its earliest encounters, Ekanite appeared in the gem-bearing alluvial gravels of Sri Lanka's Uva province. Miners didn't know what to call it. Its color resembled green tourmaline or chrysoberyl. Faceting houses in the 1960s treated it like any other novelty material. Polish it, mount it, price it low. Its behavior under light seemed normal. Its chemistry, however, was not. The more closely labs looked, the more unusual it became. It didn't fluoresce. It produced unreadable interference patterns under polarized light. Its refractive index fluctuated from one test to the next. Then came the radiation readings. By the 1980s, most gem labs refused to issue reports on Ekanite. No gemological institute would certify it as safe for sale. It wasn't banned, but it was quietly removed from catalogs, exhibitions, and auction rooms. The radioactive signature wasn't strong enough to pose immediate harm, but it was high enough to require classification. In countries such as Germany, Japan, and the United States, the transportation and storage of hazardous materials are subject to specific regulations. In others, customs officers seized it and never logged it again. Unlike other unstable materials such as opal, Ekanite doesn't crack. It doesn't craze. It stays whole. But internally, the silicate framework collapses over time. A gem-quality crystal may lose its optical clarity in a matter of decades. It doesn't fade. It fogs. It doesn't wear. It warps. Cut stones begin to dim and cloud, especially when exposed to heat or light. And once the structure is lost, no treatment can reverse it. No annealing, no stabilization, no repolish, just a quiet drift into disarray. What's left today is sparse. A 1.8 carat oval resides in Berlin, housed in a climate-controlled drawer at the Museum for Naturkunde. A broken 4-carat fragment lies in a university archive in Novosibirsk, used not for display, but for tracking the decay of isotopes. One raw crystal remains uncut, still labeled by hand, wrapped in lead-lined cloth, cataloged but never seen. There is no market for Ekanite, no synthetic alternative, no simulation. Its rarity cannot be replicated because it is not its form that defines it, but its behavior. That behavior is why no collector can predict what an Ekanite gem will become in 10 years, why no jeweler will insure it, why will no customs broker risk clearing it. Today, Ekanite circulates primarily in academic journals rather than in trade publications. It is visible in thin sections under a microscope. It's cited, not sold. Students of radiogeology measure the metamict index. They graph its structural decay curves. They compare alpha emission rates across localized zones of thorium. And when their data is complete, the sample is sealed again, unread by light. There are no treatments, no enhancements, no color grades, just slow disintegration. And when that's done, no brilliance, no shadow, no sale, and nothing else to add. Ranked 11th. Londonite, the gem with no commercial source. No shipment request was filed, No customs declaration listed it. When the samples arrived, they were examined, documented, and returned without objection. Not because they lacked value, because no value system had a place for them. Londonite emerged during mineralogical surveys in Madagascar's Ansongombado pegmatites, an area already known for its complex borate minerals. The discovery occurred in the late 1990s, and by 2001, the mineral had been verified, named, and added to academic catalogs. It was a trigonal cesium-aluminium borate with high structural stability, moderate hardness, and transparent clarity in select specimens. Its chemical formula included cesium, a rare component in gem mineralogy. Its structure was distinct. Its classification is unquestioned, but its future was undecided. Initial specimens showed pale yellow tones with high refractive clarity. A few were faceted successfully, resulting in clean symmetrical cuts with optical precision. The stones were stable under the heat. They exhibited no pleochroism, fluorescence, or anomalous behavior. On paper, Londonite met every technical requirement for use in fine jewelry, but there was no one waiting to receive it. Unlike tourmaline, it had no history of trade. Unlike zircon, it had no fire. Unlike spinel, it had no royal legacy. Londonite was new, and it arrived without story, without mythology, and without demand. A few mineral dealers attempted to introduce it to gem circles. A sample was shown at a Bharat symposium in Japan. Another entered the mineral collection of a European university, but no retailer listed it, no certification lab promoted it, and no country issued it an export code. Londonite didn't fail in the market. It simply never entered. Its structure, while sound, offered no distinguishing optical signature. Its color, while refined, was too subtle for showrooms. Its rarity, though real, had no context for comparison. It was neither rare enough to warrant exclusivity nor familiar enough to breed curiosity. It was a gem in chemical terms, but not in commercial terms. Some samples remain in institutional archives. Others were likely discarded. Londonite was never synthesized, never treated, and never copied. The total number of cut stones known to exist is estimated in single digits. No auction listing has included one. No carat price has been established. No theft report has been filed. No fraud attempt has ever been recorded. There is no mythology, no scandal, no heritage. Londonite is allowed. It is not controversial. It is not misunderstood. It is simply unrequested. In gemological databases, it is listed as an accepted species, approved by the IMA, with crystallographic and spectroscopic data available. But it is not included in educational curricula, trade manuals, or gemstone pricing indexes. Londonite has a name, a structure, a place of origin, and nothing else. No jewelry house has adopted it. No designer has mounted it. No collector has commissioned it. It does not exist in any luxury collection, nor has it been cited in estate records. Its absence is not symbolic. It is literal. Londonite is not missing. It was never part of the system. It quietly bypassed it. Ranked 10th, Hackmanite. The color-changing gem you never knew existed. The change was visible. One moment, the stone appeared lavender gray. Then after 10 minutes of sunlight, it deepened, faint violet across the surface, as if the color had returned from somewhere hidden. No treatment, no coating, just time. Most observers noted the shift. Fewer asked why it happened. Even fewer knew what the stone was. Hackmanite, a rare tenebrescent variety of sodalite, has been misidentified for over a century. It first appeared in Greenland, officially described in 1901. At the time, its optical properties were noted, but not understood. The gem was cataloged. It was named. And then quietly, it was shelved. What makes Hackmanite unique is not its chemical composition. It shares a base structure with sodalite, but its behavior under light. Specifically, it exhibits tenebrescence, a reversible color change that occurs when exposed to UV radiation or darkness. Only a few minerals in the world display this phenomenon, and Hackmanite does it with subtlety that often goes unnoticed. For decades, Hackmanite was mistaken for low-grade sodalite. Its soft coloration and modest hardness made it unsuitable for mass-market jewelry. Without evident brilliance or fire, it was dismissed as ornamental filler. Even among collectors, it remained obscure, until the Afghanistan material surfaced. In the early 2000s, miners in Sarisang, Badakhshan, began extracting specimens with unusually strong tenebrescence. Pale stones turned vivid violet under sunlight. Under shortwave UV, they fluoresced neon purple. Unlike synthetic color change stones, this shift wasn't fixed. It was living, reversible, repeatable. Collectors noticed, gemologists ran tests, articles circulated, but the market stayed silent. Why? Because Hackmanite breaks the rules of visual permanence. Its color is unstable in the display. Its classification confuses even experienced traders. Some specimens change color only once, then reset slowly over hours or days. Others refuse to respond unless cooled or warmed. There is no standard response, no grading system, no treatment protocol. In Canada, small pockets of Hackmanite in Quebec showed similar effects, but with milder shifts. In Myanmar, some samples showed tenebrescence but no fluorescence. In Tanzania, results varied from stone to stone, sometimes within the same pocket. Hackmanite defies consistency. That alone makes it difficult to commercialize. Designers need reliability. Jewelers need durability. Laboratories need replicable results. Hackmanite offers none. And yet, among a small group of collectors and researchers, it has become a subject of deep interest. Not because it is beautiful, but because it is active. It reacts. It remembers light. It forgets. It recalls. In a way, it behaves like no other gemstone does. There are no global dealers specializing in Hackmanite. No synthetic version is widely produced. No treatments are available to enhance or control its behavior. It is either present in the stone or not, and if not, no amount of heat, pressure, or irradiation can create it. Most buyers have never heard the name. Those who often confuse it with dyed sodalite. The few who understand what it is usually don't sell it. They test it, they observe, they wait for it to change again. Hackmanite is not a stone that demands attention. It requires time. And in the world of modern gem commerce, time is rarely allocated to anything that can't be promised in advance. The color returns, then fades, then returns, quietly, whether anyone is watching or not. Ranked 9th, Maw Sit Sit, the Burmese green with unknown parentage. The laboratory report was inconclusive. Mineral traces, cosmochlore, jadeite, albite. Optical behavior, inconsistent. Classification, uncertain. The sample was cataloged, but the note in the margin remained. Identity unresolved. That margin became the entire story of Maw Sit Sit. First recognized in 1963 by Swiss gemologist Edouard Gubelin, the stone took its name directly from the village in northern Myanmar where it was found. Unlike jadeite, it was not a single mineral species. Unlike nephrite, it carried no consistent tremolite signature. Instead, it was a composite of several silicate minerals, compressed into a green mass that mimicked jade, but could not be jade. Under the microscope, Maw Sit Sit reveals cosmochlore, chromium-rich pyroxene responsible for its deep emerald tone, alongside jadeite fragments and albite intergrowths. Sometimes the ratios shift, producing lighter bands, sometimes darker. No two samples are identical. For that reason, gemologists have never agreed on a definitive formula. In the Burmese trade, the distinction is blurred intentionally. Maw Sit Sit has often been marketed as jade, its bright polish and deep color making it a proper substitute. But once laboratories weigh in, the label collapses. Auction houses hesitate to use the word jade. Collectors hesitate to assign it the same symbolic value. What remains is a stone caught between categories. Production has never been large. Maw Sit Sit originates from a single locality near Kansi in northern Myanmar. Extraction is limited, and cutting is usually done locally. Many cabochons enter regional markets, but few reach international dealers. When they do, the descriptions vary: green jade, chloromelanite, or simply Burmese Maw Sit Sit. Each phrase acknowledges its presence, but none defines it fully. The stone's hardness, between 6 and 7 on the Mohs scale, allows it to be polished, but also means it can scratch or fracture more easily than genuine jadeite. Its structure is granular, not fibrous. Its durability is functional, not exceptional. And its value depends less on intrinsic properties than on how closely it resembles jade while not being jade. Over decades, Maw Sit Sit has surfaced in private collections, sometimes mislabeled, sometimes accurately described, and often misunderstood. A cabochon may appear in a jade exhibition, only to be withdrawn after gemological testing. A pendant may sell as jade, only to be reclassified later. In every case, the outcome is the same: recognition of its existence, but not its lineage. Unlike Londonite, Maw Sit Sit has a visible trade presence. Unlike Hackmanite, it does not require any special conditions to reveal its qualities. However, unlike either, it remains in a permanent state of identity confusion. No regulation bans it. No mythology sanctifies it. No consensus defines it. Today, when Maw Sit Sit appears at auction, the catalog entry typically includes caveats such as not jadeite, composite material, and identity disputed. Prices vary wildly. Some pieces sell well, relying solely on color. Others fail to attract bids. The market reflects uncertainty as much as rarity. And so Maw Sit Sit endures, a green stone mined from a single valley, cut and polished for decades, known but not defined. Its presence in gemology is undeniable. Its classification is unsettled. Its parentage is unresolved. The stone itself remains, on display, in drawers and hands, a permanent object with an undefined name. Ranked 8th, Clinohumite, gemstone found inside olivine. The Moscow Fersman Mineralogical Museum lists it as Clinohumite, Pamir, Tajikistan, a transparent orange stone, just over 5 carats, mounted for study, not for sale. Visitors pass the display without pause. To most, it resembles garnet. To specialists, it represents the rarest outcome of an uncommon mineral. Gem-quality clinohumite was first discovered in the late 20th century. In Tajikistan's Pamir Mountains, miners extracting spinel occasionally found crystals of unusual color: burnt orange, sometimes reddish-brown, occasionally golden. Unlike the spinel, these stones initially resisted classification. Only later did analysis confirm them as clinohumite, a mineral previously regarded as too opaque, too granular, too minor to cut. The Pamir finds changed that assumption. For the first time, clinohumite could be faceted. For the first time, it was entered into gemological records as a potential collectible. Before that, reports came from East Africa, specifically Tanzania, where small fragments emerged from peridot-bearing deposits. Most were too included to polish. A few specimens reached Western dealers in the 1980s, mislabeled and sold as unusual garnet or sphene. They vanished quickly into collections, often without proper identification. Further back, clinohumite had been known in Russia, near Lake Baikal. Not gem material, just massive, opaque crystals within metamorphic rocks. Mineralogists logged it, indexed it, and moved on. No jewelry use was ever considered. Its presence was academic. Furthermore, at the origin, the 1790s, Vesuvius, Italy. The first description placed clinohumite within altered volcanic rock associated with minerals of the humite group. There, it was no more than an accessory phase in Poudretteite, microscopic, unremarkable, known only to researchers cataloging the mineral assemblages of an active volcano. 2 centuries later, that accessory mineral appeared as cutstone, not through deliberate mining, but by accident, piggybacking on spinel and peridot extraction, showing itself in places where no one expected it. Always secondary, always hidden inside something else. Today, clinohumite has no commercial industry. It is not mined directly, it is not graded, it is not promoted. Cut specimens remain few, estimated to be fewer than 100 above 1 carat worldwide. Museums house some private collections, as well as a few more. No standard pricing exists. No synthetic counterpart has been created. No treatment is applied. Its gemological profile remains a curiosity. The refractive index overlaps with that of garnet. Birefringence is minimal, and the absorption spectrum is irregular. Color alone distinguishes it, and even then, only sometimes. Reverse the timeline, and Clinohumite disappears again. Back into olivine, back into Poudretteite, back into the pegmatites of Tajikistan and Tanzania. It does not stand alone. It exists inside other stones, in narrow zones, under exacting pressures. The gemstone is the exception, the mineral, the rule. Clinohumite remains what it has always been, an inclusion that occasionally escapes its host. Not enough to build an industry, not sufficient to shape a market, enough only to remind specialists that the boundaries of gemology are wider than the list suggests. The display case in Moscow holds one. The rest are scattered, uncounted. Beyond that, nothing further remains. Ranked 7th, Taaffeite, accidentally discovered in a box of spinels. In 1945, a parcel of spinels circulated through Dublin. All were already cut, inspected, and labeled. Yet one oval stone, lavender pink in tone and weighing 1.41 carats, did not behave like the others. Under magnification, it revealed double refraction, an optical property not typically observed in spinel. That anomaly alone marked it as different. Count Edward Charles Richard Taaffeite, an Austrian-Irish gemologist, meticulously recorded the details and, in doing so, created an entirely new entry in the gemological record. The mineral was confirmed as beryllium magnesium aluminum 4-oxygen-8, a species previously unknown, and was named Taaffeite in his honor. Unlike every other recognized gem, its story began not in a mine, but in a box of stones that were already polished for sale. Once its identity was confirmed, researchers traced rough material back to Sri Lanka, where small transparent crystals occasionally appeared in alluvial gravels. Later, Myanmar and Tanzania added a few more sources, and in the last few decades, China has also done so. The supply has always been inconsistent. Most crystals are small, heavily included, or opaque. Stones over 5 carats are considered exceptional, and even when found, they rarely reach the clarity needed for cutting. A few museums retain reference samples. London's Natural History Museum holds one, and the Smithsonian holds another. Private collections in Asia and Europe are believed to have more, but documentation is limited and fragmented. The stone's physical properties explain both its resemblance to spinel and its rarity in the trade. Taaffeite has a hardness of 8 to 8.5, slightly above that of spinel, and exhibits weak birefringence alongside subtle pleochroism. Its colors vary from mauve to violet and pink, depending on the angle of view. However, to most gem dealers, it remains indistinguishable from spinel without the use of proper instruments. Countless stones have likely passed through the market mislabeled, unrecognized, and unrecorded. Auction records tell a sparse story. Over the past 30 years, only a handful of faceted Taaffeites have been publicly displayed, most weighing under 1 carat. Reports of larger stones exist, but few have been verified. No continuous supply chain has developed, no major jeweler has adopted it, and no government has issued an export code to separate it from spinel. As a result, Taaffeite is absent from the systems that usually define a gemstone, such as pricing tables, trade reports, educational curricula, or cultural narratives. Its rarity is unquestioned, but it is a rarity without a story. Unlike sapphire or ruby, it has no ancient legends associated with it. Unlike jade, it carries no symbolism. Unlike diamond, it has no industrial utility. It exists purely as a gemological record, discovered by chance, recognized by anomaly, and preserved in fragments. The number of identified stones worldwide is estimated to be below 1,000, scattered across continents without reliable provenance. Some are housed in museums, others in laboratories, and many are in private hands with incomplete paperwork. The file remains open. Taaffeite has no cultural lore, no continuous history, and no secure count. It begins with a mistake, one misfit stone in a box of spinels, and continues as a record still waiting to be filled. The archive is incomplete. The entries continue. Ranked 6th, Poudretteite, gem from a family-owned quarry. The first fragments appeared in the 1960s at Mont Saint-Hilaire, a quarry in Quebec run by the Poudretteite family. The site was renowned among mineralogists for its unusual silicates and rare borates, and the small pinkish crystals found there were cataloged but not highly valued. They were too small, too fractured, and too soft to enter the gem trade. For 2 decades, Poudretteite remained nothing more than a reference name, attached to a mineral that could be studied under a microscope, but never cut into a stone. In 1987, the species was formally described and named in honor of the family that operated the quarry. With that, the mineral entered the literature, but not the market. The record stayed quiet until Mogok, Myanmar, produced a surprise. Around the year 2000, a handful of transparent crystals were recovered from gem-bearing gravels. Unlike the fragments from Quebec, these were large enough to cut. Their pale lilac and rose tones were distinct, their internal structure relatively clean, and their size, measured in carats rather than millimeters, made them suitable for faceting. For the first time, Poudretteite was more than an entry in mineralogical abstracts. It was a gemstone. The excitement did not last. Mogok yielded only a few such crystals. Most were under 2 carats after cutting, clouded by inclusions or stress fractures. Only one stone, a 9.41 carat faceted oval, showed the scale and clarity needed to become a museum specimen. That single stone, now part of the Los Angeles County Natural History Museum collection, remains the defining reference for the species. It is the image that appears in textbooks and auction notes, the piece used to represent what Poudretteite looks like at its best. Yet the qualities that make the stone visually appealing, its transparency and soft coloration, are undermined by its physical limitations. With a hardness of 5 on the Mohs scale, Poudretteite scratches easily. It is brittle under pressure. Its surfaces lose polish and wear. Jewelers quickly recognized that it could not sustain the demands of rings or bracelets. Even as collectors admired the color, they understood the material was impractical. The stone could be shown, cut, and cataloged. It could not be used. In Canada, the original quarry never produced gem-quality material. In Myanmar, there was no systematic mining, no production schedule, no export chain. Reports of a few crystals surfaced, then faded again. Without supply, there could be no pricing structure, no classification tiers, no trade. The story is not of a gem that failed. It is of one who never had a chance to begin. Today, Poudretteite exists in fragments, a museum piece in Los Angeles, scattered specimens in private hands, small crystals in drawers labeled reference only. It is listed in mineral databases and approved by scientific committees, but it does not appear in retail. It does not circulate in auctions. It does not hold space in gemological education, except as a footnote to rarity. The numbers remain uncounted, but the pattern is clear. There are too few stones to build a history and too little supply to shape a market. The mineral was found, named, rediscovered, and briefly cut. Beyond that, the file stops. Ranked 5th, Hauyne, neon blue in a tiny crystal. In a glass case, a fragment no larger than a fingernail sits under directed light. The color is immediate, electric blue, luminous even in shadow, the kind of saturation that defies scale. The label reads, Hauyne, Vesuvius. No price, no date, no context beyond its name. The object is its own justification. Hauyne belongs to the sodalite group, a feldspathoid that forms in volcanic environments rich in alkali. Its chemistry combines sodium, calcium, aluminium, silicon, and sulfate, producing crystals with a cubic framework and a hue that approaches neon. Most specimens are opaque, friable, or clouded with inclusions. Very rarely does the mineral develop with sufficient clarity for cutting. Those stones, when they appear, are microscopic by gem standards, fractions of a carat, sometimes less than a millimeter across. Despite their size, cut Hauyne gems are unmistakable. Their color rivals lapis lazuli, surpasses most sapphires, and holds even under dim light. But they cannot sustain use. With a hardness of only 5.5 to 6, they scratch easily. Their brittle structure makes them prone to fracture during the setting process. For jewelers, Hauyne is impractical. For collectors, it is essential. The mineral was named in the late 18th century for René Just Hauyne, the French crystallographer whose work defined much of modern mineralogy. Early specimens came from the volcanic fields around Mount Vesuvius in Italy, and later from the Eifel region in Germany. Both localities remain classic sources, but they produce crystals too small for commercial cutting. Afghanistan and Pakistan have yielded slightly larger pieces, enough for experimental facetting, but never sufficient to establish a supply. Auction records are almost silent. A few listings note Hauyne faceted, usually under 1 carat, sometimes priced not by carat weight but by provenance. Museums hold reference samples, such as those in Paris, London, and Berlin. Each crystal is catalogued more as a mineral specimen than as a gemstone. In trade manuals, Hauyne appears in appendices, never in the main text. Its gemological significance lies not in its size but in its optical intensity. The neon blue hue comes from sulfur content within its lattice, producing a saturation rarely matched by other minerals. Under certain lighting, the blue appears to extend beyond the physical boundaries of the crystal. But the stone remains what it is, small, fragile, without a path to mass use. The record of Hauyne as jewelry is scattered. A pendant here, a ring there, each surviving more as curiosity than adornment. Pieces do not circulate long, wear damages them quickly. Most survive only as loose stones, kept in boxes, stored for viewing rather than wearing. Dealers list them rarely. Buyers search for them specifically. And yet in gemological discussions, Hauyne holds a place disproportionate to its presence. It exemplifies the idea of a gemstone defined not by its durability or market value, but by its sheer optical character. Its brightness is undeniable, even if its endurance is not. The case in the museum shows exactly that. One crystal held in suspension, blue that resists forgetting, and a size that resists use. There is no broader story. The stone itself is the record. Ranked fourth, Grandidierite, blue-green with almost no supply. A faceted stone appeared in auction records in 2015. Its weight was under 2 carats, its origin was Madagascar, and its color was a deep blue-green that shifted under the light. The lot attracted attention, not for size but for the name, Grandidierite. Until then, most gemologists had never seen one outside of textbooks. Grandidierite had been known for over a century, first described in 1902 by the French mineralogist Alfred Lacroix. It was named in honor of Alfred Grandidier, a naturalist who spent his career documenting Madagascar's geology. The stone was remarkable in its chemistry and structure, a borosilicate with strong pleochroism, displaying blue, green, and nearly colorless hues in different orientations. But the crystals found at that time were opaque, small, or fractured. For decades, the mineral existed only as rough fragments in academic drawers. Its rarity was measured not by price, but by silence. No jewelry houses listed it, no dealers offered it. Museums held only opaque samples. For nearly 100 years, Grandidierite was absent from the gem world, a mineral more often cited than seen. Then in the early 2000s, a few transparent crystals were found in southern Madagascar. Testing confirmed their identity. Cutting was attempted. The result, stones of extraordinary saturation, combining sea blue and forest green in the same body. Their optical behavior, pleochroic flashes of multiple colors, made them instantly distinctive. But the supply was minimal. A few carats here, a handful of stones there. No consistent production followed. The gem trade recognized the significance but could not build upon it. Without continuity, there could be no pricing models, no tiers, no grading categories. Each stone had to be judged individually. Each appeared in isolation, without a companion to compare. Auction catalogs listed occasional examples from 2014 onwards. A stone of 4.3 carats was discovered in 2017, and another of 5.5 carats was found in 2019. Each drew headlines within specialist circles, then disappeared into private collections. The number of known faceted stones above 1 carat remains counted in dozens, not hundreds. No parcel has ever been offered. No jewelry line has ever featured it. Gemologically, Grandidierite should be viable. Its hardness of 7.5 gives it durability. Its refractive indices provide brilliance. Its pleochroism offers uniqueness. Yet its occurrence is too limited, its crystals are too small, and its supply is too fragile. Mining reports from Madagascar indicate that transparent sections are exceptions within opaque masses. The stone cannot be scaled. As a result, Grandidierite remains defined by what is missing. There is no steady output, no market recognition, no broad collector base, no tradition. Its presence is limited to a handful of stones, photographed, documented, and stored under lock and key. Its absence is what gives it identity, a gemstone that should exist in quantity but does not. The 2015 auction stone now sits in a private collection. The museums still display opaque fragments. Laboratories still note its optical traits. Beyond that, there is little to add. The mineral was discovered, named, identified, and occasionally cut into gemstones. In every sense that matters to trade, it remains unavailable. The record stands with gaps unfilled, and the gaps are the record. Ranked third, Serendibite, a gem rarer than almost any other. In 2005, an auction catalog listed a gem that drew immediate attention. The lot was small, only a few carats, but the description referred to it as Serendibite. The price escalated not because of demand, but because of recognition. Few in the room had ever seen one before. Fewer still had handled it. For most, the stone had been little more than a word in gemological references. Serendibite was first identified in Sri Lanka in 1902. Its name derived from the island's ancient Arabic title, Serendib. The material found there was opaque, dark, and compact, an unusual silicate with a complex chemistry, catalogued by Alfred Lacroix. It was initially classified as a rare mineral but did not enter the realm of gemology. For nearly a century, only a handful of opaque crystals were known, held in museum collections. No jewelry was cut, no trade was recorded. The silence broke in Mogok, Myanmar. During the early 2000s, miners working traditional gem gravels encountered crystals of serendibite that were transparent enough to facet. The colors ranged from deep indigo to vivid blue-green. These were unlike the opaque fragments of Sri Lanka. These were gems. Reports spread quickly through specialist circles. Laboratories confirmed the identity. Auction houses prepared entries. Collectors took note, but there was no supply behind the discovery. The crystals appeared sporadically, often small, often fractured, rarely clean. Faceted stones above 2 carats were extraordinary. Above 5 carats, nearly unheard of. The rarity was not relative, it was absolute. By comparison, there are more known red diamonds than faceted serendibites. This scarcity defined its market presence. A few stones surfaced in Geneva and Hong Kong auctions, sometimes fetching hundreds of thousands of dollars per carat. Beyond those isolated events, the stone remained invisible. No retailer listed it, no jewelry house featured it. The gemological press noted its existence, but never published price guides. Serendibite's properties are not in question. It is hard enough for jewelry. It has high refractive indices, giving it brilliance. Its colors, when present, are saturated and unique. Yet none of this matters without continuity of supply. The stone cannot sustain a trade, cannot sustain an industry, cannot even sustain awareness beyond circles of specialists. The majority of people who know its name will never see it. The majority who see it will never own it. For most, Serendibite is a mineral in a book, not a stone in a case. Its history is measured in gaps, its presence in absences. No mine production, no dealer listings, no tradition recorded. What remains are fragments of records, a museum in Colombo with opaque samples from a century ago, a few faceted stones in private collections, and auction listings that appear only once every few years. These fragments are sufficient to confirm its reality, but not enough to establish its precise location. Serendibite remains what it was at the beginning, a name in mineralogy, not a product of commerce. It is known, it is documented, it is recognized, but it is not present. Ranked second, Painite, once the rarest gem in the world. Today, Painite is no longer the rarest gemstone. Hundreds of crystals exist, most in drawers, some in laboratories, a few in collections. The supply is no longer a mystery, and the name no longer carries the weight of singularity. Yet its reputation persists, a reminder that rarity can be temporary. In the early 2000s, mining around Mogok in Myanmar began to reveal new crystals. The discoveries ended the notion that painite was unique. Small prismatic pieces, often dark brown or reddish in color, were confirmed by spectroscopy and indexed. Some could be cut into stones under 1 carat. Others remained opaque or fractured. Collectors gained access, and the scientific record expanded. Painite left the category of one of a kind and entered the category of rare but known. Rewind 2 decades, and the picture is different. In 1980, the total number of painite specimens recognized worldwide was 2. Both were housed in institutions, all of which were non-commercial and opaque. Gemology books of the time referred to it not as a gemstone, but as a mineral curiosity unlikely ever to appear in jewelry. Guinness World Records listed it as the rarest gem mineral on Earth. For collectors, it was absent. For the public, it was invisible. Further back still, the record narrows to 1. In 1951, Arthur Charles Davy Payne, a British mineralogist working in Myanmar, submitted a crystal to the British Museum. It was brownish red, hexagonal, and initially thought to be spinel. Later analysis revealed a new mineral species, complex in composition, that incorporates calcium, zirconium, boron, aluminium, silicon, and oxygen. The stone was named after its discoverer, Painite. For years, that single specimen defined the entire species. For half a century, Painite existed as a line in mineralogical abstracts and a solitary stone in a case. No second crystal was identified until the 1970s, and even then, it remained uncut. The stone's status as rarest was not based on value, beauty, or desirability. It was based on numbers: 1, then 2, and nothing more. Its properties, when considered, should have allowed it to compete. With a hardness of 8, it is durable. With refractive indices similar to spinel, it can display brightness. With its iron and chromium content, it exhibits red to brownish-red hues. But none of that mattered when no material existed to cut. For decades, the stone's reputation was built on absence, not presence. The turn of the 21st century changed that. As Myanmar opened limited access to gem localities, researchers and miners identified more painite, enough to challenge its singularity, but not enough to commercialize it. By 2005, the count had risen into the hundreds. Today, estimates suggest that several thousand crystals exist, but only a fraction are fastable, and even fewer reach collections outside Myanmar. Painite's story, traced backwards, illustrates the fragility of rarity. From hundreds of pieces today, to a handful in the late 20th century, to a single stone in 1951, its narrative contracts until it nearly disappears. What began as a single crystal evolved into a mineral species, then a legend of scarcity, and ultimately became a modest reality. The record ends where it began. A lone crystal, mislabeled, later corrected, placed in a drawer. The rest of the story unfolds outward from that single point, but the center remains unchanged. In first place, Jeremejevite, a transparent mystery from Namibia. Under the exhibition light, the stone is almost invisible. Its body is clear, edges crisp, reflections faintly tinged with blue. The label states only, Jeremejevite, Erongo, Namibia. No price accompanies the name, no record of sale. Jeremejevite is aluminium borat fluoride, a mineral first described in Siberia in 1883. For decades, it remained a mineralogical rarity, recognized in textbooks but absent from jewelry. The crystals found were small, often fractured, and rarely transparent. The mineral bore a name, but not a function. The shift occurred in the late 20th century, when Namibia's Erongo region began producing crystals of unusual size and clarity. For the first time, Jeremejevite could be cut into gemstones. Their hues ranged from colorless to pale sky blue, sometimes golden. Their hardness allowed durability. Their transparency allowed brilliance. Faceted stones were produced, and yet no commercial market followed. The reasons are numerical. The number of gem-quality Jeremejevite crystals recovered is vanishingly small. Stones above 2 carats are scarce. Stones above 10 carats are almost mythical. No consistent mining has ever been documented. No parcel of Jeremejevite has circulated in trade. Each stone exists individually, discovered by chance, cut experimentally, and then withdrawn into private hands or museum collections. auction houses have listed a handful. In Geneva, one pale blue oval under 3 carats. In Hong Kong, a colorless cushion of a similar size. Prices reached high figures, but the sales were anomalies, not precedents. Catalogs treated the stones as curiosities. Collectors bid not for investment, but for possession of what few others had seen. Gemological testing confirms the rarity but does not expand it. The mineral is pleochroic, showing colorless and blue orientations. Its refractive indices overlap with topaz. Its hardness overlaps with quartz. In every measurable way, Jeremejevite resembles familiar stones. What sets it apart is not its performance, but its absence. The history of its occurrence underscores that absence. Siberia produced the first fragments, none of which were transparent. Myanmar yielded occasional crystals, but most were too small to be of commercial value. Namibia remains the only locality to produce faceable material in any consistent form, and even there, production was limited to a brief window. No new deposits have been recorded at scale. In collections, Jeremejevite sits quietly. Museums rarely display it, as the stones are too small to impress a public audience and too rare to risk exposure. Private collectors may own examples, but records are sparse. The total global count of cut stones remains unknown, though the number is believed to be in the low hundreds at most. Unlike sapphire, it has no lore. Unlike diamond, no industry. Unlike jade, it has no cultural weight. Jeremejevite exists in gemology as a technical fact, with measurements, properties, and a handful of specimens to confirm its existence. Beyond that, there is nothing. The exhibition light reflects again off the Orongo stone. It refracts faintly and then remains unchanged. The record ends with the object itself, and the rest is silence. The survey ends where it began, in records rather than in markets. Each of the 15 stones exists, verified by chemistry, recognized by laboratories, and preserved in collections. Yet none has moved into the systems that define gemstones for most of the world. They remain detached from trade routes, jewelry houses, and cultural stories that usually give stones their place. Some are fragments in museum drawers. Some are single-faceted stones in private hands. Some are known only through brief mentions in journals with no accompanying photographs. Their significance lies not in circulation, but in survival. As an archive, the list is currently complete, but it remains incomplete in practice. Other stones may surface. Other records may be corrected. Other specimens may disappear. What is certain is that these 15 do not belong to the categories that shape the gem market. They belong to the margins, documented, stored, and rarely seen.